Good afternoon. Well, welcome to today's class with Mr. Ogemde Manuel Okeke. In our today's class, we will be looking at application of integration. And here comes a question from Godman. The tangent at a equals 2, 8 on the curve y equals x raised to power 3 meets the curve again at b. Find the coordinates of the point B and the area enclosed by the arc AB of the curve and the tangent. Okay, the solution. The curve y equals x cubed can be sketched through the points that satisfies it at 1, 1, that is when x is 1, y is also 1, minus 1, minus 1, that is when x is minus 1, y is also minus 1. Then 2, 8, that is when x is 2, y is 8, and minus 2, minus 8, when x is minus 2, y is minus 8, and many other points. So we can use these points to sketch. So let's find the gradient of the tangent at the point 2, 8. So here we differentiate y. The y dx is equals to 3x squared. So at x equals to 2, the y dx is equals to 3 of 2 squared, which is equals to 12. So the gradient of the tangent is 12. Equation of the tangent and the curve. The equation of the tangent is given using the equation of a line y minus 8 is equals to 12 of x minus 2. So y is equals to 12x minus 24 plus 8. So y is equals to 12x minus 16. That is the equation of the tangent. So we have points of intersection of the curve and the tangent by solving the two of them simultaneously. So we have x cubed is equals to 12x minus 16. Therefore, x cubed minus 12x plus 16 is equals to 0. Using synthetic division, we already know the points. One of the points that satisfied the equation is 2, 8. So let's use 2 as a factor of this equation. Using synthetic division, we pick the coefficient of 1, 0, minus 12, 16. That is, 1 is for x cubed. There is no x squared, so we replace that as 0. Then x, the coefficient is minus 12. Then 16 is the constant term. So we bring down 1 first. We say 2 times 1 gives us 2. 0 plus 2 gives us 2. 2 times 2 gives us 4. Minus 12 plus 4 gives us minus 8. So 2 times minus 8 gives us minus 16. 16 plus minus 16 is 0. That shows that x minus 2 is a factor of this equation. So we try the 2 again. Using the 2 to divide 1, 2 minus 8. So we have bring down 1. Then we have 2 times 1 gives us 2. 2 plus 2 is 4. 2 times 4 is 8. Minus 8 plus 8 is 0, which shows that the 2 is also a factor of the second one. So we have the equation completely as x minus 2 times x minus 2 times x plus 4. So we have x minus 2 squared times x plus 4. So the zeros of this equation, or the solution to this equation, is minus 2 is 2 twice and minus 4. So the point of intersection of the curve and the tangent is x equals to 2 twice and minus 4. So to find the area enclosed between the tangent and the curve, we use the integration of the equation of the linear minus the equation of the curve to get the area enclosed. So that gives us, the integration gives us 6x squared minus 16x minus x raised to the power 4 over 4. So the point of intersection I have already shown as 2 and minus 4. So if we substitute 2, we will have 6 into 2 squared minus 16 into 2 minus 2 raised to the power 4 over 4. So that gives us 24 minus 32 minus 4, which gives us minus 12. So when we substitute minus 4, we will have minus 96. So the area enclosed by the tangent and the curve is negative 108. Since we are looking for the area of the enclosure, we use the absolute value. So the area of the enclosed between the tangent and the curve is 108 squared units. Now to find the coordinate of the point B, we already have the second point as x equals minus 4. We substitute it. So we have y is equals to 12x minus 16. That means 12 times minus 4 minus 16, which is minus 48 minus 16, which is negative 64. So the coordinate of the point B is minus 4 minus 64. Thank you for being part of our class today. Please do well to interact with us at the comment section by asking us or writing to us for more clarity. Please, you can reach us through this contact 080-387-46884. Do us a favor, share our videos. If you feel that there is something in it, let some other person enjoy it. Please share our video so it can reach at any point. Thank you. God bless you.